Thank you so much. All right, glad to be here with you, and sorry to be here only virtually. I'll be talking about co-evolving with artificial beings, a project dear to my heart. And maybe to understand a bit of the context and where I'm coming from, I'll give you a bit of my own background, which I started in machine learning. I created a few companies, mostly in Europe and the US. And then I went back and did focus on research that was in Tokyo. My PhD was mostly on collective learning. And then I spent some time in the US and focused more on cognitive sciences and the sciences of consciousness. That has influenced my studies until today, and I have founded a bunch of different initiatives. I won't list everything, but mostly things are oriented towards artificial life, AI ethics, and machine learning applied in the industry. My main project right now would be Cross Labs. We are located in Kyoto, here in wonderful Japan that just reopened, so please visit anytime. And our focus is really the study of diverse intelligences. We try to bridge our research between the industry and academia. And it's really about integrating this longer term vision into just solving problems. And we apply our research through AI company Cross Compass and major players, mostly in manufacturing here in Japan and also internationally. I want to say hi to my team, co-founders, and our whole team of researchers, and also many students that come and go. It's thanks to them that we can do all our research. And really, our research is focused on fundamental topics, so rather long-term kind of topics. And here are three of them. One of my favorite is collective intelligence, how to have AIs communicate and transfer their knowledge between different embodiments. The second one would be open-ended learning, how to avoid machine learning from plateauing and rather continuing to learn forever. And the last one, of course, how to integrate a mathematical study of consciousness in diverse types of beings. For every single topic, we focus on rather mathematical approaches, and that integrates well with machine learning. We teach those topics and go way beyond current state of deep learning and integrate physics, biology, cognitive sciences, neuroscience in different ways. We also disseminate our research. Everything at Cross Labs is completely open, and we collaborate with diverse universities here in Japan and internationally, and created our own journal that is also free and open. We participate in different activities and have created a few of our own. We are very engaged in the Society of Artificial Life. I'm the VP currently of the society, and also various activities that I will mention towards the end. And one of them is Human Flourishing. We'll have a conference in 2 weeks in Kathmandu, Nepal, about how to find ways to see the self differently through the lens of new discoveries in AI in the future of humanity. So I'll jump into the core, and this will be rather short. I'll just make 5 quick points, and hopefully you'll see a bit of my perspective of how we can co-evolve with AI. And the first one is to realize, of course, like other speakers have mentioned, we are at the gate of a new era in terms of artificial intelligence, and we have noticed that amazing exponential growth of computation, not only, but also software type of learning. So layers of computations are able to accumulate different compressions of reality, different more and more adaptive models of reality. And that allows us to play very high level shogi or go or chess, many video games, but also we have evolved in creation of texts, understanding of language at very high level. We can also use those large language models. I'm sure you're all aware here that we can use that to produce amazing art, but also solve those same large language models can now help us solve concrete problems. Not only so this is the fun one, of course, the captioning songs live. This one's from Billie Jean, of course, Michael Jackson. So all of that is all fun, but you can also apply those language models into something. You can use them as reservoirs, really, to compute complicated predictions such as protein structure, starting with DeepMind, but other groups have replicated the work through language models instead. So we work a lot on that. But now, a little bit of the sad moment is that we realize that we can't make autonomous robots quite yet. We can't make fully human level AI, as people say. It's because this is a very difficult task. So how can we achieve that? How can we go the next step into creating autonomous beings? So here comes the approach of artificial life or synthetic biology. And we try to, this is just a piece of art created by a famous Dutch artist, but it really symbolizes how we want our system to be. We want it to be this piece, this engine, where we understand different mechanisms and we implement them in order to use the energy, free energy from sensors and so on, and integrate that in terms of principles into a machine that feeds itself and maintains itself in an autopoietic manner, so maintaining its own homeostasis. There are many computer simulations that you can see. This is one that you might have coded as a student, or you've seen it around. This is, of course, The Game of Life by John Conway, a famous physicist. And turns out that with very simple rules you can implement in this fictitious kind of physics, you can implement entities that maintain themselves and start learning. Actually, you can implement a machine that is fully Turing complete. So all this environment can compute anything and can simulate any kind of computable element in it. You can change the rules and have entities that are more complex with more dimensions, with different types of physics. And yeah, I won't go too much into that, but my field studies a lot those simulations, and especially how those can emerge from nothing. You just have the laws of physics, and just like on Earth, you would have an emergent learning mechanism. Of course, if you add on top evolution, that's something that different people at OpenAI, also DeepMind, and ourselves too, have focused on, and you can reach very complex kind of behaviors through that bias. So you can have plenty of artificial words where you can do that. We do that in video games as well. This is an example of continuous cellular automaton for those who are fond of this. Again, reaching sort of forms of life in this weird, strange, fictitious physical world. So those are simulated. But of course, we can bring them closer to humans by implementing some kind of robotic system. And this is Scary Beauty that we presented in 2018 at a conference of artificial life in Japan, in Tokyo. And it directed a nice philharmonic orchestra. Those robots can interact with those same principles in the real world. Now, what's our next challenge? It's really combining this orchestra and the tool, but also this companion that we have that is robotic or artificial. And that's not something new. We see it in biology in the past, and we extract those fundamental principles from biology that we understand now through study of mathematical biology, evolutionary biology, into the study of artificial simulations and robotics to understand really how to apply that and understand the nature of a real coevolution and cooperation between a synthetic mechanism and an existing living system that is biological or a slightly different, maybe some weird kind of biology. I won't go too much into details, but there's plenty of things to explore in there. My fourth point would be on how those have to be synergistic, so how they have to be helpful to each other. And the fundamental difference that I want to point out, and this may be the highlight for me of this message today, is that there are two types of tools. One is the simple mere calculator that you might be using right on your phone. Oh, I need to calculate something, I do this. I need to go to this place, I'll just use Google Maps or whatever mapping system. Or this robot will help me. Actually, all those tools don't get you to sense through them. They're giving you a service, and the channel of communication with you is very, very narrow. Whereas tools as simple as a blind person's cane, or these glasses, or science, different disciplines, allow you to see through them. And one very nice example of those tools is, of course, the soroban, or abacus, different names in different countries. But this kind of device allows you to, just by learning how to use it, compute amazing things, understand deeply mathematics. And this is the kind of tools that we want to create at Cross Labs to augment, expand human intelligence instead of delegating it to other tools. And this is the whole difference that you have to understand. And we really understand this much better now from examples in biology. So this just as an example of what I talked about in terms of fundamental principles. This pushes us also towards a deep thinking in terms of philosophy of what we are doing, really, what we are creating. And we want to be very mindful of possible dangers, but also possible misconceptions that we might hold. And of course, we are writing our own future now with this coevolution of what we are creating and ourselves as creations that emerge in the world. So we do different works. I just mentioned the last couple of minutes a few efforts that we are involved in. One is, of course, the ethics, the rights of future artificial living systems, including rights of robots, which naturally expand to rights and consideration for all sorts of living beings. So not only humans, but especially we put an accent on hybrid beings. We have a lot of research and workshop series going on in new kinds of cybernetics. Again, how you can augment different creatures, including humans, with tools, and we have plenty of experiments in that. This is a fun example where we talk with bacteria, and we use language models to do a sort of conversion and actually create oishi, delicious pickles, which is plenty of fun. But also, you can manage an extension of this research to talk with your own cells or some of your organs, which is very exciting. Okay, so a few other ones. This is a project in India. We work with different countries around, including Vietnam, China, India, the Philippines. And we have different networks that help us communicate. And this is one about revitalizing cities from the bottom up. And we use similar approaches. I won't go into details in this. This is another one on the study of the origins of consciousness in the universe. This is a fun one that we've been working on on understanding the nature of the self and ethics between Buddhism and new AI principles, creating a dictionary to really try and do better in the future in terms of, well, mindfulness and also care for all beings. So we'll have a conference on that topic. So relatedly, starting a new grant from next year, and understanding really the new meaning for self in the future, that those selves that might be hybrid. All right, I thank you here, and yeah, I welcome any questions. Please feel free to contact me as well if you'd like.
Thank you, Dr. Witkowski.
I should probably.
Can you hear us?
Yes.
Okay, great. Yeah, it's interesting to see the what's possible now with some of the new large language models and foundational models, as well as how the advances in artificial life from the machine learning side kind of complement also what we've been doing from the cognitive science and complex systems side. So I think we got time for a couple questions we can take. Is any from the crowd here or else online?
Hi. Hello. Can you hear me?
Yes.
Yeah. Actually, I think it's the interesting topic. I'm curious about what's the topic of coevolving, coevolution. At first, I think that you were creating Robocop, right? But after that, I'm curious what on earth they can co-evaluate all together. Like that the sapient cannot live with the Neanderthal, right? Created another one. So what is integral? What is dominant? And how you can resolve conflict between two species, for example, to them to co-evolve? Yep.
Yeah, it's a very interesting question. Sorry, I'm removing these for feedback. I think it's difficult because there are plenty of resources around us, but in any kind of environment where resources are limited, at some point you are going to reach the holding capacity, right? In terms of energy resources, and the problem that animals face in small ecological niches, we might face at the scale of the planet. So this is understanding this is a lesson for us humans to see into what to do in the future, not to fight each other. And I think there's no real difference between fighting between a predator and a prey, and what future we may reach if we are not careful. So I think this is a very relevant question, and studying these principles also allows us to understand the meaning of care, really, in those difficult situations where maybe you might think that we don't have a choice and we have to choose between saving you or saving you. And you've heard about those trolley problems, right? And that's the first thing we looked at in our studies. It turns out that we think that there's a concept of care that we can extend that can help us for this. So I invite you to read our research on this without expanding too much today, but thank you for your interest.
Thank you, Olaf. I think that's all we have time for today, unfortunately, but thank you for coming and talking with us today.
Thanks so much.
Who is the founder of BNH.ai. It's one of the